once again, because we had the 45 triangles in here that divide our circle into 8 chunks, and our 36, 90 divide our circle into 12 chunks. So because 8 and 12 both go to 24, we make 2 pi be 24 squares. 24 squares. And you want as much as you can in the negative. Okay, you need a calculator, by the way. You don't already have one. And I want you to take calculators and I want you to put them in radian mode. We're big kids now. Let's graph cosine first, simply because it's easier to graph first. I think it'll be easier for you guys. We haven't actually started it, so we'll graph cosine first. Okay, we have 24 squares. Yeah. Oh dear. Yeah, you are, because we're not going to be on this scale. We don't number. Just need to count 24 squares. That's all. Okay, here we go. So I know cosine starts at 0, ends at 2 pi. Yeah? Halfway between 0 and 2 pi is 12 squares, right?
Yeah.
So what would that be?
Pi.
Pi. What would be halfway in between 0 and pi?
Pi over 2.
Pi over 2. It's just unit circle knowledge, right, guys? Yes?
So it's 6.
That's 6 squares. What's halfway between pi and 2 pi?
3 pi.
3 pi over 2. Now wait, what's halfway between pi and pi over 2? 0 and pi over 2?
Pi over 4.
Yeah, guys, it's just knowing your unit circle, right? Here's 0, here's pi over 2. What's halfway between them? Pi over 4. So at those 3 squares, that's going to be pi over 4. And guess what? I can count from here on out. Pi over 4, 2 pi over 4, which is pi over 2, correct? Go another 3, this should be 3 pi over 4. All I'm doing is counting. The next one is 4 pi over 4, which is pi. Next one is 5 pi over 4. 6 pi over 4, which is already there. Then 7 pi over 4. Once I figured out that 3 squares is pi over 4, I can just count after that. Yeah? Now let's figure out if pi over 2 is what, 6 squares? You guys agree with that? How much would pi over 6 be? If this whole thing was 6 squares, 2, because then it'd be 2, 4, 6, right? So every 2 squares, I have my pi over 6. The next one I can just count, guys. 2 pi over 6 is then pi over 3, correct? 3 pi over 6 is already there. Another 2 squares, I have 4 pi over 6, which is actually just 2 pi over 3, because we're on my unit circle. 5 pi over 6. I'm just following my unit circle here. 7 pi over 6. 4 pi over 3. 5 pi over 3. 11 pi over 6. And if you don't know your unit circle, ouch, this is going to hurt, because you can't do your scale without knowing your unit circle. And notice they're all in order. And it should make sense, because think about this. Don't I have like a group of 3 kind of close together? Space? Group of 3 kind of close together? Look at your circle. Don't I have kind of like 3 lines close together? It's uneven space? So it's not even. I don't have to label every single one. Now I put 1, about 4 squares, so I'm a nice big graph. So think about how high does cosine actually go? 1. So that's how I know I have a max of 1. So now at 0. At 0, what is cosine at 0? Unit circle.
0 or 1.
Cosine is 1. You agree with that? So I'm going to put a dot up at 1. At pi over 6. be a decimal for square root of 3 over 2. And we have to approximately. 0.866, so pretty darn close to 1, right? So here's 0.75, so I'd say about here. Yeah? At pi over 4, what is cosine? And I'm going to put over here so we don't have to find these values again. Square root of 3 is about 0.86, right? Square root of 2 over 2 is what?
0.707.
It's about 0.7. Here's 0.75, so a little below. Pi over 3, what is cosine? 1 half. You don't need a calculator for that one, that's 0.5. Pi over 2, what is cosine? 0. At 2 pi over 3, what is cosine?
Negative 1 half.
Negative 1 half, correct? I'm going to go negative a half. 3 pi over 4, cosine is? Here's 0.75, so a little below it. 5 pi over 6, cosine is?
I can't really get it.
Negative square root of 3 over 2.
I told you to put in the middle of the page. Why do you not have?
No, it's just because where I'm marking.
Because of why?
Where I label it.
I don't understand.
If I go negative 1 half, it'd be.
Oh, you're fine. You draw through, but you're not. You didn't follow my scale. I want 1 to be 4 squares.
Oh.
Yeah. Okay, so 5 pi over 6, we get 0.86 again, right? Negative? Right? Pi, what is cosine? Negative 1. 7 pi over 6.
Negative square root of 3.
Negative square root of 2, so the same thing. 5 pi over 4.
Negative square root of 2 over 2.
Negative square root of 2 over 2. 4 pi over 3.
Negative 1.
Negative half. You're already seeing it? 3 pi over 2, cosine is
2.
0. 5 pi over 3, so almost done here. What is cosine? 5 pi over 3?
So it's 1 half.
1 half. How about 7 pi over 4?
Square root of 2 over 2.
Square root 2 over 2. 11 pi over 6? Square root of 3 over 2. And 2 pi. Now, this is a curve. Do not try to connect the dots. Try to make it as curvy as possible. Now, in the negative direction, it's going to do the exact same thing. It's symmetrical. Ball behind there on the bottom points.
Put that in there.
Beautiful. So draw a little bit in the negative. It's just going to be reflection. Right? So if you have room, draw kind of a reflection on the other side. And voila! There's cosine. How beautiful. We have to know this inside and out. So I'm going to ask you questions. I'm going to be like, where does cosine have a max? Where does it have a max?
2 pi. Or
At 2 pi, also at
1 or 0.
0. I could ask, what is the max? You would tell me 1 in that case. I would ask, where is it 0?
Pi over 2 or 3 pi over 2.
3 pi over 2. Where is there a minimum?
Pi.
Pi. The key thing to note is cosine starts and ends the same spot up top. And it's symmetrical in between. Yes? So you start and end at a max, in between is a min. Is that clear? Because the scale will be changing here next week. Questions? Okay. Now I'm going to jump ahead to for you. You don't need to write this down, I have this handout for you. We're going to kind of keep track of some of these properties here. But first we need a vocab word, and yes, go ahead and laugh. Every year, people laugh at this definition. Period is how long it takes to complete one cycle before it repeats. I know, it's every year, never fails, I know, go ahead and laugh, it is a silly definition. But it's how long it takes before it repeats, basically. So look at your graph of cosine. It's going to do the same thing over and over and over and over again.
Where do you want us to put this at?
Wherever you want. It's up to you. That's what cosine does in both directions. Over and over and over and over again. It's periodic. That's what cosine is called. It's called a periodic graph because it has a period. It does the same thing over and over and over again. Now, looking at your graph, how long can I go before it starts doing the same thing over and over again? 2 pi. Go from 0 to 2 pi, and it does the exact same thing, right? One way to tell the period easily is pick like a max and a max, subtract them, because that's that distance, right? So pick some good characteristic, maybe a min and a min, until you get back there. But see, if I started up top here, I don't get back to that spot until 2 pi, but then I should do the exact same thing. So the period of cosine is 2 pi. That's exactly what I'm going to write. The period is 2 pi. Now, it does not mean what do you see. Like up here, see I have more than one period? I have a little bit more? Doesn't matter. It's how long it took until I get max, until I get to the max. Now, look at the domain. That's your x's, right? Are there any holes, jumps, asymptotes? You see any problems? Louder. Do you see any holes?
No.
Do you see any jumps?
No.
Do you see any asymptotes?
No.
So do you see any problems?
No.
No. So what do you think my domain is? There are no problems. Come on, guys. My domain's all real numbers. That goes back to Math 2, Math 3 right there. You have to know domain and range. You can't graduate high school without knowing domain and range. Okay? No problems. Everything I can put in, I can plug in any number I want. Take cosine of 57. It works. Cosine of 152 over 93. It works. I can put in anything because there's no problems. Now looking at the range. Do I get everything out? No. In fact, I only get what?
1 through
Negative 1 to 1. Put it in interval notation, right? That is negative 1 to 1, bracket or parenthesis. Can I be negative 1?
Yeah, bracket.
Yes, bracket. We already got the period. Now the zeros. Ooh. We already said there are a couple zeros.
How did you see negative 1?
Negative 1 to 1.
Oh.
And also from unit circle, right? We know that the smallest I can be is negative 1. How many zeros do I have? Okay. How many zeros do I have?
5.
How many zeros do I have?
Infinite.
An infinite amount. This goes on forever and ever and ever, correct? So I need to figure out some way of writing that I have an infinite amount. So here's what you do. Where does the first positive zero occur?
2 or pi over 2.
You guys agree this is the first one? So this is what I do. I write the first one. The first zero occurs at pi over 2. Now, what's the distance between each zero? How far is that? Pi over 2 to 3 pi over 2. Look at the circle. It's pi. It's half a circle, correct? So this distance is pi, correct? So I'm going to put plus pi n, where n is any integer. Getting our symbols now. Remember that's my is a member of, the little e, epsilon. Stuff doesn't go go away is what we started with the year. Here's what I'm saying. You pick any n that's an integer. So n is 2. So if I take pi over 2 and I add 2 pi, I can get another 0. If n is negative 1, subtract pi, I get another 0. So no matter what n is, I'm going to get another 0. Yeah? Beautiful. I expect you to know this graph inside and out, and the properties. Got it? Okay, let's do tangent. The sign is very similar. So, same scale, copy down. Make graph, chop, chop.